Welcome, my friends. Consider this system of linear inequalities, which we would like to graph. The first step is to get both inequalities into slope-intercept form. The second one already is, so we just have to modify the first one. If we add 3x to both sides, we get negative y is greater than or equal to 3x plus 3. Next, we need to divide both sides by negative 1 to clear the negative off the y. We are left with y is less than or equal to negative 3x minus 3. Remember that if you multiply or divide an inequality by a negative number, you must flip the inequality sign, which is why the inequality switched from greater than or equal to less than or equal to here. So our two inequalities are y is less than or equal to negative 3x minus 3 and y is less than 4x plus 3. We want to know what values for x and y satisfy both inequalities. Most likely, there will be more than one value. Start by simply graphing the two lines. For y is less than or equal to negative 3x minus 3, we have a y-intercept of negative 3, so the point 0, negative 3 is on the graph. Then we can use the idea of rise over run to graph another point, 3 down and 1 to the right. But that won't fit onto my graph. Instead of going down 3 units and going 1 to the right, I can go up 3 units and 1 to the left to find an additional point. We can connect the dots to draw the line. For y is less than 4x plus 3, we have a y-intercept of 3, so the point 0, 3 is on the line. We would normally have another point up 4 and 1 to the right, but again that would put us off the page. Instead of up 4 and 1 to the right, we can go down 4 and 1 to the left to find another point on the line. We can connect the dots to draw our line, but since we have a less than sign and not a less than or equal to sign, we use a dotted line to indicate that points on the line are not included in the solution. Alright, there are a few ways to think about what to do next. Since I'm making this video to prep you for finding linear programming solutions by graphing, my preferred method is to cross out the parts of the graph that are not satisfied by the inequality. What I mean is, y is less than or equal to negative 3x minus 3 indicates a particular region on the graph, and y is less than 4x plus 3 indicates a different region on the graph. My preference, which I'll admit is not the mainstream way to solve a problem like this, but I have a reason for doing it this way, I promise, is to cross out all of the regions of the graph not consistent with both inequalities. Let's think about y is less than or equal to negative 3x minus 3. There are two sides of this line, over here and over here. Only one of these sides is consistent with the inequality, and the other side is not consistent with the inequality. I want to find the side that is not consistent with the inequality and cross it off. So how do you know which side is which? One way is to plug in a point, most commonly 0, 0. If we plug in 0, 0, we get 0 is less than or equal to negative 3, as the x term will disappear. This is a false statement, which means that the side of the line y is less than or equal to negative 3x minus 3 with 0, 0 on it is inconsistent with the inequality. So I'm going to cross off that portion of the graph. If you plug in 0, 0 to y is less than 4x plus 3, you get 0 is less than 3. This is a true statement. 0 is indeed less than 3. That means that the section of the graph with 0, 0 makes the blue equation true. So we cross off the other side. Now, if you've done this correctly, there should emerge some area on the graph you have not crossed out. This is the solution set. So anywhere in white here is the solution to the set of inequalities. For example, the point 0, negative 4 would make both inequalities true if you plugged it in. The more traditional approach is to shade the part of the graph that does make the inequality true, and the solution set will end up being the portion of the graph that gets shaded twice. The reason I don't like that approach is, if you have more than two inequalities, you end up needing to look for the region that gets shaded 3, 4, or even 5 times, and it gets very confusing and hard to keep track of. For a larger number of inequalities, it is much cleaner to think about crossing out the portion of the graph that makes the inequality false, which is what we will be doing. Let's try another problem. Say we have this system of linear inequalities. Again, the first step is to solve each inequality for y. I'll do them together. We can add 3x to the first inequality and subtract 3x from the second inequality to get 5y is greater than 3x minus 5, and 7y is less than or equal to negative 3x minus 14. Then we need to divide by the coefficient on y, which is 5 in the first inequality and 7 in the second. We get y is greater than 3/5 x minus 1 for the first inequality, and y is less than or equal to negative 3/7 x minus 2 for the second. Next, let's graph the lines. We have a y-intercept on the first inequality of negative 1, so 0, negative 1 is a point. And then we can graph another point using the slope by going 3 up and 5 to the right. We can connect the dots in a dotted line, since we have strictly greater than and not greater than or equal to. For the second inequality, we have a y-intercept of negative 2, so the point 0, negative 2 is on the graph. I haven't given enough room on the graph to get another point with the slope in either direction, but we can find the x-intercept by plugging in y equals 0 and solving for x. We get x is equal to negative 14 over 3, which is about negative 4.67. So the point negative 14 over 3, 0 is on the graph. We can connect the dots in a solid line, since we have less than or equal to. Now I'm going to show you a shortcut for knowing which side of the line to cross out. For the first line in red, we have greater than. For greater, think above. Anything above the line is part of the solution set, which would be anything up here. Since the method I'm using crosses out the part of the graph that is not consistent with the inequality, we must cross off the opposite side, down here. If this doesn't completely make sense to you, or if you aren't sure, you can always plug in a point. Usually 0, 0 works, as long as it isn't on your line. You would get 0 is greater than negative 1, which is a true statement, meaning this part of the graph is consistent with the solution, meaning we should cross off the other side, which I've already done. For the other line, we have less than, which means anything below that line is part of the solution. This area down here is below the line, so that means we must cross off the other part of the line, up here. Here is the solution. We have one area of the graph that did not get crossed off, which is our solution set. Any point in the unshaded region is consistent with both inequalities. Okay, let's try one more problem with 3 inequalities. Thankfully, all 3 inequalities are already solved for y, with the exception of the first one, which does not even have a y. Recall that x equals a constant is just a vertical line. So x is less than or equal to negative 5 will just be a vertical line at x equals negative 5 before we shade. For the second inequality, we have the point 0, negative 3, and then we can get another point 2 units down and 1 to the right. We can get another point by going 2 units up and 1 to the left. We can connect the dots with a dotted line due to the less than sign. For the third inequality, we have a y-intercept at 0, 5, and then we have a point 2 units up and 1 to the right. We can also go 2 units down and 1 to the left to get a third point. We can connect the dots in a dotted line. Now we need to do the shading. For x is less than or equal to negative 5, you might be wondering how to do the shortcut. What part of the graph is above x is equal to negative 5? Well, there really isn't an area above, since we have a vertical line. But if you use some common sense, you know that the values for x that are less than or equal to negative 5 would be anything negative 5 or smaller, like negative 5, negative 6, negative 7, etc. That means this area of the graph over here is consistent with x is less than or equal to negative 5, and means I should cross off the opposite side of the graph, which is over here. For the second inequality, I have less than, so I am below the blue line. So I cross off the opposite side above the blue line. For the third inequality, I have greater than, which means the area above the line is part of the solution. So I cross off the opposite side below the green line. There is only one area not crossed off, which is over here on the far left side of the graph, which is the solution set. Alright, my friends, that completes my video over graphing linear inequalities.